Assalamualaikum warahmatullahi wabarakatuh. We are from MB2. So now we are presenting to you our structure for molecular geometry and molecular polarity. For now, we have C2H2 structure, and then we have our level structure. So now from our level structure, in order to find the molecular geometry, we need to find to find the total pairs of electrons. Which there are two different central atoms now, C1 and C2. So now we must focus on either this central atom or this central atom. So for me, I will take this central atom. So to calculate that, there are two sigma bond for this central atom, which is this sigma bond and this sigma bond, because in this triple bond we don't take the pi, so we need to take the sigma bonding pairs only. So there are two total of electron bonding pairs. So after we have found the two sigma bonding pairs, we can find its electron pair geometry, which is linear because there are two bonding pairs. So its BSEPR plus will be MB2. So when we want to draw its molecular geometry, we must start from its skeleton. So we must start from MB2. We know it's A, B, and then B. So from this we can draw like this because there are two different central atoms. So its bond angle is 180 and 180 because I made this because there are two bonds here and here. So there are 180 degree and 180 degree. So its molecular geometry will be linear because there are no lone pairs and its BSPR plus is MB2.
So this is the molecular geometry for C2H2.
Okay, after we found its molecular geometry, we need to find its molecular polarity. So we know, in order to find molecular polarity, we need to know its bond dipole. But bond dipole only exists when they are in different atoms. So for each central atom, we know that between C and C, there are no bond dipole. So there are no bond dipole, and between C and H, there are also no bond dipole because its electronegativity between C and H are very similar. So we cannot draw a bond dipole between C and H. So we can conclude that C and H and C has no bond dipole. So its resultant dipole moment is equal to 0. So when a resultant dipole moment is equal to 0, it is a non-polar molecule.
So polarity of NH4+. As we know, the formula geometry is AB4 and the electron pair geometry is tetrahedral. For this shape, we know that all NH bond has bond dipole. Each bond dipole can cancel out each other. So the mu is equal to 0. This is because it is symmetrical molecule that is basic shape with same terminal atom, which is hydrogen. So this shape's called as non-polar molecule.
So we move at the next structure, which is SnCl3-. So before we start a molecular geometry, we need to determine how many total electron pair on this structure. This is sigma bond. This is sigma bond for bonding pair. This is sigma bond for bonding pair. This is sigma bond for lone pair. So the total for electron pair on this structure is 4. So the electron pair geometry for SnCl3- is tetrahedral. It's called as, so BSEPR for plus on this structure is AB3E. So after we determine how the many total electron pair and electron pair geometry, then that's all. We need to draw a molecular geometry for this structure SnCl3-. So the SnCl3-, we draw like this. So the SnCl3- at the angle on this structure is less than 109.5. This is because we have a lone pair on this structure. So this lone pair will cause the repulsion for this bonding pair and it will reduce the angle. So the name for this molecular geometry called as trigonal pyramidal. So we need to determine the molecular polarity for this structure SnCl3-. So this is a bond dipole on this structure. So SnCl bond has bond dipole. The last part is molecular polarity. How to determine molecular polarity? So look at this structure. Is all CnCl bond has a bond dipole. This is a SnCl bond has a bond dipole, and the other one is a lone pair at the central atom give a rise to a resultant dipole moment. Hence, this is a unsymmetrical molecule. So the molecular polarity of this structure resultant dipole moment not equal 0. Hence, this molecule is polar molecule.
Okay, come back with me for structure number 15. For CLF3, we have put our layer structure and we need to find its molecular geometry. So in order to find this molecular geometry, we need to find its total electron pair, which is from the layer structure we can get its total of 5. Why it is 5? It is 5 because it consists of 3 sigma bonding pairs, which is between CLF, and CLF. Then we have a total of 2 lone pair bonding, which is on the central atom, our central atom, which is chlorine. We have 2 lone pair. So the total electron pair is 5. So we can now know the electron pair geometry, which is trigonal bipyramidal. So its BSEPR class will be MB2. The shape, the molecular geometry for this structure is this. Why is this? Because from the beginning we need to draw this skeleton. We have 2 lone pair bonding. So we remove our 2 and make it lone pair. So we can get this shape, which is T shape, which is our molecular geometry. So the bond angle between the linear and the planar is less than 90 degrees because the repulsion of lone pair will decrease the degree between planar and linear. And between linear and linear will be less than 180 degrees because of the lone pair repulsion. So next, we need to find its molecular polarity. So in order to find its molecular polarity, we need to know its bond dipole. So in this molecular geometry, we can now draw our bond dipole. Lone pair has its own bond dipole, so we can draw it towards the outside and the outside. So it is a non-pair bonding. So for our bonding between CL and F, they are bond dipole too. So the bond dipole will be towards chlorine, which is more electronegativity than chlorine. So the bond dipole will be like this. So as a result, the F between F and CL bond has bond dipole. Yes. And lone pair on the central atom gives rise to the resultant dipole moment. So this bond dipole cannot be cancelled out by this bond dipole because it has different value. So the resultant dipole moment will equals to not equals to 0. So it is a polar molecule.
Polarity of SbF6-. Formula geometry is AB6 and the electron pair geometry is octahedral. These shapes state that all SbF bond has bond dipole, which is polar bond. All bond dipole can be cancelled out with each other. It's also a symmetrical molecule that is basic shapes with same terminal atoms, which is fluorine. So the mu is equal to 0, so this shape called as non-polar molecule.
Okay, so we move at the last structure, which is SeF5+. So before we start to draw a molecular geometry, we need to draw a layer structure first. So this layer structure for SeF5+. So this structure on this SeF5, which is SeF5+, have a 5 sigma. This is on the each bonding. First 5 sigma, and for 1 sigma for the lone pair, sigma lone pair. So the total on this structure is 6. 5 sigma bonding pair and 1 sigma lone pair. Okay. So electron pair geometry for this structure is called as a octahedral. So The SEPR class is MB5E. This is SEF plus for molecular geometry. So look at this structure. So this on the body and another body is less than 90. Because of why? You know, the eccentric atom has a lone pair, one sigma lone pair. So this one sigma lone pair give that cause a repulsion on the other bonding, and cause the angle will be less than 90. So the molecular geometry called as a square pyramidal. So we go the last part to determine the molecular polarity. So how to determine the molecular polarity first? So the first point is SE bond has a bond dipole, which is at this SE, and F bond has a bond dipole, this and this. And the other one is a lone pair on the central atom give rise to resultant dipole moment, which is at this central atom give a dipole moment. So this structure can cancel with each other because have a different value with each bond dipole. So the resultant dipole moment mu not equal 0. And the last one is this is a polar molecule.